Today we are going to learn about electromagnetism, its origin, all the relevant laws of electromagnetism, mathematical deduction related to each topic gradually in different chapters. We will initiate our study by understanding the introductory part of this topic. Now, electromagnetics, or more precisely called electrodynamics, is a classical branch of physics or electrical engineering, where electrical and magnetic phenomena are studied. And it is also regarded as the study of the interactions between electric charges at rest and in motion. It has numerous applications, such as in plasmas, nuclear research, fiber optics, electromagnetic interference, electromechanical energy conversion, radar meteorology, remote sensing. It is also used extensively in medical science, such as electromagnetic power in microwaves used to heat deep tissues to stimulate certain physiological responses to relieve certain pathological conditions. Electromagnetic devices such as transformers, electric relays, radio or televisions, electric motors, transmission lines, antenna, waveguides, optical fibers, lasers, and so on. So, design of these devices required the complete or extensive knowledge of the laws and principles of electromagnetism. So, in search of the origin of electrodynamics, it is very much essential to understand the four realms of mechanics. Those realms are: first one is the classical mechanics or Newtonian mechanics. Here it is inadequate to explain phenomena where objects moving at very high speeds, means close to the speed of light. To overcome this, new theory called special relativity comes into effect, and it is developed by Albert Einstein. But here the problem is it cannot applicable for extremely small objects such as atoms. Then the new one come. It is called the quantum mechanics. It was developed by Bohr, Heisenberg, Schrödinger, and others. Though it resolved the problem arise in special relativity, but cannot applicable to the objects. Those objects are both very fast and very small. Then the next one came. It is called the quantum field theory. It is actually developed by Dirac, Pauli, Feynman, and many other physicists. The problem arised in quantum mechanics mitigated here. It actually combines the quantum principles of relativity, so that it is applicable to those objects that are very fast and very small too. Now we will understand the most fundamental forces in nature. In mechanics, it describes that when a system subjected to a given force, how it will behave. So, to understand this, first we will understand what kind of fundamental forces that are present in nature. We found that four kind of forces, that is fundamental forces in nature. The first one is called a strong force. It is actually effective over very short range. It dominates only at the level of subatomic particles, and it holds protons, neutrons together in the atomic nucleus. The second one is the electromagnetic force. It is weaker than the strong force, and it has infinite range but many times stronger than gravity, such as friction, chemical force that bind molecules together, tensions and elasticity, and many more are the examples of electromagnetic forces. And third one is called the weak force. It is weaker than strong force as well as electromagnetic force. It is effective only over a very short range. It dominates only at the level of subatomic particles, and it observed in radioactive decay phenomena. And fourth one is called the gravitational force, and it is the weakest of all four fundamental forces, and it is, as the weakest force, it has an infinite range. Thanks for today, and in next topic we will understand laws of electromagnetism.